Section 1.2 Limits of Functions. So far, we have been estimating limits numerically and graphically. Each of these approaches produces an estimate of the limit. In this section, we will study analytic techniques for evaluating limits. The first approach is direct substitution. It's based on the following rule. Let b and c be real numbers, and let n be a positive integer. Then the limit as x approaches c of a constant b equals b. And the limit as x approaches c of the variable x is just c, so you replace x by c. And the limit as x approaches c, x to the nth power equals, replace x by c, c to the nth power. Let's take a look at example number 1 on how to use this rule. So we evaluate part A of the limit, and limit as negative 8x plus 3 to the third power. Because it's a polynomial, okay, it satisfies it having a constant, having a variable, and variable raised to some power. Then we can just direct substitute 0 for x. So we have negative 8 times 0 plus 3 to the third power. Now make sure you use a calculator. It's just 3 to the third power, so it's 27. That's the limit. Now for the next limit, we do the same thing. We try to use direct substitution first, unless we have a problem. So we have 1 squared plus 1 plus 2 divided by 1 plus 1. So it's 4 over 2. The final answer is 2. And the limit for this square root radical polynomial, we substitute x by 0. So we get square root of 0 squared plus 4. Square root of 4 is 2. And if you're not sure, just plug this into your calculator to get the exact answer. Now part D, limit as x approach pi, sine pi square. Okay, so this is what it really means, is sine of pi, and then you square. Now what is the sine of pi? You can use a calculator. It's 0. So 0 squared is just 0. This is how you use direct substitution. Very straightforward.